let's remember to record today. What a day this is. So, hope we are all doing okay today. Come back over here, please. Google Slides has been fighting me with something crazy lately. I fixed my... Oh, good. Glad to hear it. What was the problem? Out of curiosity. Or is it worth talking about out of class? So, okay. That makes sense. Good. Glad that got fixed. All right, so we have a few things to talk about today. And then we'll get into test-driven development. So first and foremost, welcome to the first online-only day of the semester for everybody. Nice thing about this class is that we were online only from the get-go. And what that means to you, Ducky helped. Oh, good. Rubber duck debugging, best thing in the world. So online only, obviously all of your other classes might be different. I structured this one to be online only because at some point I figured we were going online anyway, and there's no change to all of you. So nothing changes for this class. Everything is the same. Plans keep moving forward as they were. So you don't have to stress out or worry about any quick format switches for this class. Everything's going to continue onwards as usual. Final exam time slot's still going to be your term project presentations. And yeah, life moves on for us, as usual. Other thing that is new, so I graded homeworks 3 and 4 for the group stuff, so that is up in Blackboard. You should all be able to see your comments from me on there. The homework 3 was your requirement specs and use cases. I didn't really grade too hard on the actual requirements since I did that already in your individual ones. So I was mainly looking for formatting and cohesiveness and things of that nature. So take the feedback that I gave you individually and fix things for later on. The use cases are also pretty good. I was not really too concerned. Everybody that turned in an assignment did pretty well, I would say. The only things that I kind of looked at for the use case diagrams were basically feedback on what you could do better. If you screwed up the diagram, I took a few points off, like if you're missing the boundary, or if you use squares instead of ovals, because unfortunately with use case diagrams, squares actually mean something. So if you did squares inside, you got a point or two docked, because that's a object or an actor, not a use case. And some of you did a little bit too much verbiage. If there are issues with them, do we have to fix them by the final? So I would, let's see, how do I want to phrase this? I will have requirements for your final, basically. It's going to focus more on your requirement spec than anything. So you don't necessarily have to fix them right now. I'll give you the expectations pretty soon. But yeah, I mean, overall, they're pretty good. And I don't think I docked more than a handful of points if you turn them in. So you should all be good. And then homework 4, as long as your plan was appropriate. I was mainly looking for A, did you do it? And B, does it make sense? So the feedback that I mainly gave was make sure you're avoiding scope creep, make sure that your plan is consistent, make sure that everybody's participating appropriately, because obviously it's a team effort, and if you're not participating as much, then that's harmful for your teammates and for yourself. But hopefully we can resolve all of that. All right, other things. I think that's about it. So the plan for today, then, we're going to talk about testing in a kind of backwards format. So I know all of you probably did JUnit testing in your Intro to Java class. may have some testing experience. We're going to start with unit testing. We're going to kind of move up in complexity. So today and Friday, we're going to go through test-driven development, which we'll get through. Then Monday, we'll most likely be doing an in-class lab. So that's going to be, we'll do like over Blackboard instead of through Twitch. I'll give you an announcement for all of that fun stuff. But then Wednesday, we have our break starting. So we get a nice little segue into our fall or into our winter time here. And you have homework due Monday, so make sure you all get that taken care of. Anyway, enough pitter patter. Let's talk about testing. So testing is a very broad subject. It is something that you all need to do, something that you all should be doing as you write programs, and it's probably something that most people will leave till the very end of their projects. Um, Typically, the process was always derive requirements, create design documents, write code, do testing, ship, and deliver, right? The problem with that kind of idea is that all of this time that you spent developing and then you go into your testing, basically you have two activities which are done sequentially when they could really be done in parallel and save you a lot of time. And one of the things that you're going to see is that testing doesn't necessarily just mean like unit tests, where they're little bite-sized test cases where you're checking is the output correct or not. They can be very, very complicated. They can be involved instantiating massive 3D worlds or simulation environments, maybe mocking up GUIs, something of that nature. Basically, testing is just it can be very, very complicated. And the longer you put it off, kind of the more time you can expect later on to have to put into it. And that's not counting all of the test cases that fail where you have to go back and fix your code. So this idea of test-driven development was kind of born out of the agile mindset, so the extreme programming subset of agile came up with this test-driven development idea. And basically the idea here is that you want to write your test cases first and then code, not write code and then test it. And I'm going to kind of not waffle, but I'm going to pull back a little bit as we talk about this because there are some dangers with this idea that I want you all to be aware of in your coding practices. But kind of the key takeaway here is that test-driven development, you're really building up your repertoire of test cases early on, right? You're not spending months later on deriving test cases. You're writing test code as you write your actual code. And that can save you a lot of time, a lot of effort, and actually has a lot of key benefits. So we're going to talk about two of those today. So there's the red-green refactor cycle, and then the test first stoplight cycle. These are basically two very similar, yet slightly different ideas for test-driven development. And that's pretty much what we'll be getting through today. And the fun part is we're going to end with me touching Java, and I'm going to feel horrible and gross when I write Java code, because that's just me. But next time we'll look at it in Python as well, so it'll be all okay on Friday. And what I would like to start with here is some info from you. So what would you consider a test to be? Because we haven't really talked about testing yet, right? We have talked about requirements, we've talked about artifacts, we've talked about code, we've talked about project management and how everything kind of links together, but we haven't really talked about validation yet, which is testing. I was going to ask you. Well, let's flip this classroom and I'll ask you all. So what do you think a test is? Kind of like I said, we're doing this a little bit backwards. We're going to talk about test-driven development first, and then we're going to go deep into testing. I mean, feel free to guess. That's fine. A test that makes sure your code functions as desired. That's definitely a good starting point. Way to validate that a process works. Good, very good. I'm really trying not to rock back and forth. I got into this really bad habit when I was a PhD student. So I had my first kid when I was pretty much close to defending my dissertation, and I would practice my presentations holding an infant and rocking and talking to a screen. I got in this bad habit of like rocking when I talk from that. All right, comparing data inputs, outputs, results to make sure the program works as intended. Good. That's fine. So there are some key ideas that we have here, right? So these are all perfect guesses. You're making sure that some process works. You're testing your inputs and your outputs. You're testing behavior. The key takeaway here is that, yes, we're testing things, but what are we testing them for or towards? Generally, with a test, you're going to have some kind of a requirement or an artifact backing it up, right? So for every test case you write, you'll probably link it to one or more software requirements. So that SRS that you started working on, like if you have a requirement that's, I'm trying to remember what some of your requirements are, like user clicks right arrow and player moves, for instance. Okay, you have that requirement, then you have a test case that actually makes sure that happens. Attempt to get the desired output. Yep, exactly. So basically, we are checking our code behavior. We're making sure that all of our formats, our data formats, are correct, that the behavior that's expressed is what is desired. But this all is going to be tied to those artifacts that you've been working on. That gives you that kind of sense of well-being that you know it's working correctly. All right, so does this have to be automatic? No, it can be. And we will talk about manual versus automated testing. There is a lot of really cool things you can do with some of the testing frameworks that are out there. You can write tests by hand. You can, you actually can have a checklist where I ran this test, I did this test, I did this test, and then you click done, 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 valid, 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 valid. You can have an automated test, like there's the JUnit runners, there's, all kinds of testing frameworks for that. There are even testing frameworks that are exploratory. So let's try to automatically discover new test cases, maybe discover parameters, or try to figure out all these different combinations that will cause this particular if branch to trigger. When I make changes to the group application, I just recompile and test each time. That's good. Yeah, so you have varying ways you can do testing. How do you do a test in Unity? So that's a very good question. I did start looking into that last summer, I think, because I had this idea of doing some automated testing in Unity. There are frameworks that you can build in to Unity. I think there's actually something on maybe in the Unity store, I'm not sure. It's C#, so there's a C# unit testing framework. You can leverage that for the basics. And then there are automated like test scripts that you can add into. But with Unity, you have that graphical aspect, so you have to do like effectively, game testing. It's possible. But the key here, and with this idea of testing, is that you all more or less probably know testing in terms of like unit testing, right? So you've done JUnit. If you've worked, you've probably done more in-depth testing. If you haven't, you might have this idea of what testing is. And your answers here are perfect. But keep in mind that testing isn't necessarily something where you recompile and you run it and it's done in like 1 second. Testing can take days to perform. And that's where you get into this idea of prioritizing test cases, right? Which tests should we run first? This one's going to take 5 hours to run. This one will take 20 minutes to run. This one will take 2 seconds to run. Then you also get into the notion of, do we have enough coverage? So have you covered every single path of execution? Have you checked every single function input and output? Do all the behaviors that you talk about in your requirements, are they all expressed? Is every requirement tested or not? One example with this is that I went to a keynote presentation at a conference a couple years back. I do some testing research, and the keynote was from somebody who works at Facebook, and their testing pipeline was basically that you push a change to the Facebook platform, whether it's the app or the website or any of their various applications that they have in their portfolio. You push a change up to your CI/CD pipeline, and it takes at least, I think it was like a day to 3 days for the test to finish. So imagine you all are working on a project team, you make a change, you push it up to see if it's good, and you don't get an answer back until tomorrow or the next day. How painful could that be as a developer? So there's basically going to be lots of strategies that we'll be looking into for managing testing. So the project management development was one side. Then we have our implementation. Now we have our testing. These are all really big chunks of a project. The key is to kind of get into the habit of working with tests and test cases. It's something that I am horribly bad at, writing tests as I write code. But if you can kind of get into that habit of adding tests to your code base and then having like your unit tests be available, it's always kind of good because not only are they showing that your code works, but they could be reused later on. You know, if you have another project which is similar, just kind of copy the code or the tests in. So enough grandstanding there. Here is one example of a unit test in Java. So basically this would be a mathematical type of class where, okay, we can add things together, we can check if that addition is valid or invalid. And what do we see in this? We see assertions. So assert that this addition operation is equal to 4. Assert that adding these numbers is equal to an invalid. So basically, we are checking various states of this addition operation. This is what I would kind of expect you all to know how to do. And if you don't remember, that's okay. You know, your unit testing will be more or less dependent on your term project. We'll talk about that soon. But basically, we have test cases that we write. And for unit testing, they can be simple functions. We also have integration testing, where you check your project when you bring in multiple modules. Did they still work if you link them together? You have regression testing, where you've added a new function. You have to make sure that didn't break anything else. So there's lots of different types of testing we can talk about. Here we have an example of some unit testing in C#. So your question about Unity might look something like this, where you add in a test class that can check some of your Unity specific problems. Again, you get into that graphical side with Unity, so there's better tools out there than just unit tests. But you can write test cases in whatever language you want. When we get into test-driven development here, I've got a link to a Medium article for explaining the first process, and it's actually done in Ruby. I don't know Ruby, but I can kind of understand what they're talking about there. So, out of curiosity, are you all getting double audio? Sorry, I was trying to fix my headset this morning where I was trying to use like a headphone jack instead of this USB connection, because my USB connector is right in front of my laptop where my mouse is, and that kind of broke Streamlabs. Do you have your stream open in Chrome? No, I just had two. Let me show you here. I just had two headset things up and running. No, now I broke things. No. How did I drag everything off screen? Okay. Enough of that. Anyway, so test-driven development. As long as you can all hear me and there's no weird audio glitches, that's fine. So TDD means that we have two simple rules here, and you can modify test-driven development for your own purposes, obviously. There are some common strategies, but the key is that you are writing test cases first. You don't write any code, you write tests. How do you know what to test if you don't have code? Well, you're testing your requirements, you're testing your artifacts. You know that this particular feature has to be tested, so write a test case for it. Then try to run it. Well, it's going to fail. You don't have any code for it, right? So then you write code that will pass that test case that you have created. So if you write a test case that says this string has to be all uppercase, right? Maybe it's a story-based game and you need to emphasize this particular sentence, make sure it's uppercase. Your test case would be string dot assert string dot is upper is true. So that'd be your test case. But it would fail because you don't have the code to actually do that. Then you would write code to make sure that test case passes. And then following that, you would fix your code. So reduce any complexity. If you have duplicate code anywhere because you're writing all this code to pass tests, remove that. Fix your code smells, where code smells is going to be things that seem to be wrong with your code. It smells funny is kind of the visualization there. Maybe you notice some anti-patterns being applied, like that God pattern, or any of those anti-patterns that we've seen. Maybe things are instantiated kind of funny. Just there's lots of specifics with code smells that we're not necessarily going to be getting into. But effectively, you write your test case, you hack together some code to make that test case pass, then you make it a little bit more elegant. Is kind of the takeaway. So that's the style there. You might have also heard of it as test-driven design, test-first development. Basically, the key is that you're writing tests as you go. Now, that's the general idea. We have two processes that we're going to talk about now and then a little bit of a demo. So the first one is red-green refactor. So basically, you start out by writing tests. They're going to fail because you have no code to test. You make a very minor code change. Test case passes. Then you refactor it. Go to your yellow light. So here you're going red, green, yellow. And again, if you don't like my explanation or you want to see what this looks like with Ruby code, here's a pretty decent article. But this was actually created by the person who helped create extreme programming. So this is a definite agile style of coding. So what does this actually mean? And today I learned just how many emojis there are out there, because there's even a traffic light emoji. But at the red stage, don't write code yet. Again, tests are going to fail. You have a bunch of red that you have to fix. Green stage, write your code. Doesn't have to be perfect. This is where I want to take a step back and explain. This is where it can be kind of dangerous, and only dangerous maybe if you are a novice programmer or complacent. When you write code to pass tests and you start seeing all those little green checkboxes, you think you're done. Well, no, you are not done. You've only written code that passed your tests. It is not necessarily good code. Maybe you've got some hacks in there to make it pass that you said, I'll go back and fix later. Make sure that you spend the time, if you are following this strategy, to make sure that the code you write isn't just passing tests. Right? The purpose of a test case is to make sure that your requirements are being expressed appropriately in code. It's not that you return true just to make the test case pass. There's an entire programming language consisting of emojis. Yeah, sure, go ahead. Do that. I've seen that one. Honestly, my favorite programming language that I've ever seen. Oh, I should make next semester I need to do this. So there's a programming language based around the idea, I think it's a virtue or honesty or something like that. Basically, you write preconditions and postconditions for all of your functions. So what's coming in and what's going out. Basically, you're writing like unit tests for your functions. And if your code fails, it will automatically delete that code. So it's like I want to say it was virtue or it was one of those like high level ideals. Brain F and cat code. If I can't read your code, then we might have problems though. Emoji code. Oh dear God. I need to look at this. God. Oh, yes. I assume that this was maybe made before some of these emoji took on different meanings though, huh? Anyway, so don't write your code just to pass. Next homework assignment, there you go. So the one thing too is that I want you to really consider those real-world ethical implications we talked about. Do you remember the VW problem where they're passing all their emission tests because they wrote tests that automatically passed? That's where I want you to be very, very careful that you're not just writing code to pass test cases. Having test cases is showing that you have found those bugs. There may still be problems in your code that haven't been detected yet. So that's kind of where it's tricky for me being a software engineer who has even seen real world problems where test cases that are just passing are not useful. Test cases that are functional and valid and are actually doing something are a good thing. So make sure that you write good code effectively. All right, so the other side of things here. Test first stoplight cycle. So another traffic light type of thing. Also another extreme programming type of idea. Got a link here to another article if you would like to read it. Basically here we have a very similar notion, except we have a very minute difference. So I'm actually going to walk through some code for this one too. But what we have here is we're first going to prepare a list of tests, and before we just wrote a bunch of test cases, I'm going to animate all these in. But we start with a green light, so meaning that everything's good, everything's passing. Then we start writing our tests. We still have tests written first before code. All right. Then you're going to get a yellow light, meaning that your code doesn't compile. And why doesn't it compile? Well, you haven't written that code yet. Makes sense, I hope, right? You write your tests, you're instantiating an object, checking to see what the output of a function is, but function doesn't exist, so you get a compiler error, get a yellow light. The difference here is that you're going to add a stub. So a function stub is basically just an empty function, returns nothing, or whatever appropriate data type it needs to return to make the test case work, but it's a fill in the blank type of thing. If you've ever done any automated code generation, you've probably have seen stubs generated. Basically, they're just functions with empty space. Actually, you can get function stubs in Eclipse at least, where generate the main, generate all your various gets and sets and all that. So that will be your yellow light. Then once you have the stub, you run your tests and you get failures, you get red lights, meaning that the code compiled and ran, but your test cases failed because your whatever the output of your stub doesn't match your test case. Should make sense. Again, the code is not there. Now, you implement just enough to make the test case pass. Very similar where you hack something together with the last one. Then you improve by refactoring. You go through this entire process until everything is green, and then you rinse and repeat, basically. So it's a very, very similar idea. Key difference here is we're writing function stubs as kind of a middle step in a way. With both of these procedures, the goal is basically to increase your test portfolio quicker. Decrease the interval between writing tests and production code to minutes. Again, if you separate out coding from testing, this interval could be weeks, months, days, it just depends. Here you're writing tests as you go. You, one, know exactly what the test cases should be. And then you don't have to spend all that extra time thinking, okay, what are all the tests I need to prove out these requirements? They're already there. Again, test cases are reusable too. Any project that you have with like a common class, you could reuse those test cases. You might need to tweak them a bit, but it's usually a good thing. All right, I'll talk about the benefits after this example. So here I've actually got some Java code for you. And this is based on, I've got a link later in the slides for how to do JUnit testing if you don't remember how to do it. Basically what we're doing here is we're going to instantiate a person class with a name. I'm going to skip the favorite, even though it's in the slide. It's in the link, but it's not useful for this purpose. Basically, our goal here is to create this person class and return their name as an XML entry. So basically add an XML tag around the person's name. Pretty trivial, but could be useful for an application where you're building up like an XML document or an XML database or something like that. And maybe you're generating a game state or maybe a list of customers and you want it nicely formatted in XML. So let's do that. And you get to see me kind of waffle around on Eclipse, which is going to be lots of fun for everybody. So let me pull up my stuff here. So I've got a clean slate Java project here. So I'm in Eclipse. Those of you that use JetBrains, it might look a little bit differently, but it's called the CIS350 unit test demo. All right, 14. What else do we need? Oh, so this is the other thing too. I have JUnit 4 on my computer. If you add a JUnit class, it's going to default to 5. The way my machine's set up, it's going to fail horribly when I do that. So I'm going to go ahead and add a library right now, JUnit 4, and then I've got that. Module name, create. All right. I even remembered to make or leave it big. I had this quite small in the first class. So my first Java project.exe, let's go. All right, so I need a class here. Let's call this person. It's public. Let's give it a stub for main. And we've got our package. Let's say system.out.println. I did hello there in my last class. What's a good let's use your emoji code. Ooh, let's see what this does. What? Does Java not like Unicode? Or am I just missing a semicolon? It does not like those. Weird. Harumph. Well, it was fun while it lasted. All right, hello world. We've got our basic class. Let's be millennial about it. Let's go. Perfect. All right, let's make a constructor here. So public person string in name. It might. All right, so we've got a name. This name equals in name. Alrighty, we have a person. So we've got our person. Let's add our unit tests and make sure I'm not forgetting any variables here. That looks good. All right, so new JUnit test. Let's call it. Nobody in my morning class got this JUnit. So we've got a setup and teardown function being generated to add you to the module info. Okay, so I've got my JUnit test file here. I've got a setup and a teardown function. So if you don't remember what these are, before the stuff happens, wow. I happen after things are done. Smiley face. Okay, so we've got 3 functions here: setup, teardown, test. So anything with the test decorator is the actual test case that we're running. Can we do this in Android Studio? Yeah, it's just Java or Kotlin, I guess. But any framework should have a unit testing library, I would assume, associated with it. I'm sure Android Studio does too. I'm just doing it in Eclipse because this is my entry point into Java. So before it happens, before your test cases run, after it happens when they're done, Basically, this is like if you need to instantiate something, maybe you need to set up your world state or create a bunch of entities, and then when you're done, get rid of them, because this will run in pair, or it's going to test out your actual code. These are not strictly necessary if you don't need them. The test cases will be what are run, and you see that with the test decorator. So if I now run this, I should see, yeah, okay, I keep forgetting to click that. Failures, 1. Assertion error, not yet implemented. So we see that happen. Here's our print lines going on. Let's change this to be, I am a test, doot, doot, doot. Run. So we see the order before, after, testing, right? Okay, so I'm going to get rid of these before and after because they're going to just clutter the screen up. Let's get rid of this test. So now I've got a nice clean JUnit file. And what do I care about programming-wise? I care about checking if this person's name is an XML entity, right? Because that's what I care about. Does it have a name tag around it? Because then I would dump it into an XML file later on. So smallest thing that I can test here, right? So I need to instantiate person. New person. Look at my shelf of books here. I've been wanting to read. Let's go with the whole name. Stevenson. I got a couple Neil Stevenson books I haven't gotten through yet. All right, so at test. So I need test person. And what I want to do is assert equals name Neil Stevenson. Close that off. And then I need p.asXML. Yeah, that's what I wanted to have here. Yeah, okay. Just making sure I'm following the slides right, basically. Do we need similar tests for GUI elements or just objects? Yes, so that's a good question. You need to do GUI testing as well. There are automated test runners for that, like for handling mouse clicks everywhere, filling in fields. Testing isn't just code, it's also GUIs. It's also any kind of camera-based entity. Android, if you have an Android GUI, there are test runners for that. Basically, everything needs to be tested. The Therac 25 that we talked about at the very beginning of class, if you had run an automated test suite that checked all the button presses in the order and speed at which they're applied, would have caught probably something like that. So testing isn't just silly little, unit tests like I've got here. But yeah, always test, always test, always test, always test. I guess the other thing too, I'm writing code here, is the testing isn't just, yeah, see, there's my bug function doesn't exist. We're at our yellow light because we need a stub as XML undefined. Let's write that stub. So my example is that you also have like user testing, usability testing, right? Give your Android application to 50 people and see what their feedback is. Maybe they hate your color scheme. Maybe they hate your button placement. Maybe it's the best app in the world and they give you that feedback. You then would have something tied to like your non-functional requirements. Stub public string as XML, return null. Okay, so this is my stub. It does nothing. It does have the correct method signature, meaning it returns a string. The name is correct, no function parameters. So that now matches my test case here. So I'm going to run this, and I'm going to get a failure. So before we saw an error, now we see a failure. Assertion error, expected name Neil Stevenson, but it was null. Why are there two? Sorry, I'm just looking at the error statement. There's two left angle brackets right here. Yeah, that's just part of it. All right, so how do we fix this? Pretty easy. I'm thinking my vi keys are in here. Return name plus this dot name plus name. Okay, now it's nicely formatted as XML. Run. Passed. Lights are green. We're happy. So that is a very, very simple test case that we've got going on there. Where are my slides at? Right here. Okay. Go back to present. Screen's gonna just go crazy. Full screen, pointer. Okay. So we would then iterate this too, right? I just wrote one test case, one simple stub, and then I updated it. You would probably be writing a ton of these test cases. You would have to generate whatever kind of framework or infrastructure to support this particular testing script. And maybe it's not just checking XML. Maybe you're checking every single attribute of a person. Is it in the correct range? Is it the correct data type? You have lots of different possibilities for testing to make sure that things are as they should be. But yellow, red, green, yellow, red, green, yellow, red, green, yellow, red, green, you would go through this cycle over and over again until you are satisfied that all of your requirements are being appropriately tested for this particular class. Again, this would happen over and over and over again. All right, makes sense the example there? And again, hopefully that's a review for all of you. If you don't remember JUnit testing, there's your review from last year or last semester, whenever it was. I'll show you it in Python on Friday as well. If you want to do it in any other language, you might be having to do some personal research there. You haven't ever seen it. Oh, good. I am not a JUnit person. Again, I'm not a Java person, but I was able to do it pretty easily. The thing I should mention too, so I know that there are some of you doing lots of crazy things for your term project, which is great. Some of you are using RPG Maker. Some of you are making a smart mirror, Android apps, Unity apps, straight up Java applications. You can do unit testing in all of these. It just depends on your particular, if your framework will handle it, or if you need to like write a little helper script to run that. But it's possible anywhere. You're just checking inputs and outputs, you're checking behaviors. So what are some benefits here? Let's wrap this up and why we would maybe want to do this. First, your tests actually get written, right? You're not waiting till the end of development to write your tests. You write them as you go. And what's the benefit of that? Well, other than having a nice little repository of all these test cases, you can actually check to make sure your code's working as you write it. It sounds like a little kind of like a self-fulfilling prophecy where I wrote the test case and I wrote the code to pass and then it passes and we're good. But really, I mean, if you construct your tests to, really follow your requirements or whatever artifacts you're using is kind of your rubber stamp of approval, you can actually demonstrate functioning code very early on, right? That pattern of green tests actually means something. So that's nice to demonstrate. It's also enables a nice flexibility here too. So if you ever want to take your code and extend it, right? Add a new module on, add some more functions, add some new behaviors. You can always rerun your tests. And after you've added in this new piece, you can show that your old code isn't broken anymore, or as isn't broken based on this new addition, right? Because it's possible that whatever you brought in can impact all of your other code base. And then your question is, well, did we break something from 5 weeks ago or not? Well, your test cases would show if something's working or not. And kind of the other really nice thing here too is that test cases and test specs are actually design documents. So these are going to be software artifacts that you can use to be part of your whole, software development lifecycle. You've got your requirement specs, you've got your UML models, you also will have a test spec. And whether it's automatically generated, whether it's handwritten, You're going to be able to use this as proof that your program is doing what it says it does. And why do we care about proof? Well, that enables user trust and user acceptance, right? If people, and when I say people, I mean users, I could mean auditing bodies, I could mean your management. If they look and see that you're passing your tests and your tests are understandable and explainable, we add it to the artifacts. Basically, yeah. Um, but if you can demonstrate that your code is making all of these requirements happen, then others will trust your code base, meaning that if you're a company, public trust in your company is very important. If you're an independent developer, people know that they will be getting a good product out of you, and your product will go out there and be useful. And I'm saying this not in like a nebulous, everything's wonderful fashion. Trust is very important. When I was in automotive, there was a company that started failing all their test cases, and yet they still released their stuff. And the auditing bodies found out about that. And then you start seeing contracts with automotive manufacturers dry up because you're not trustworthy anymore. You're not safety rated because all of these tests are failing. So this is actually quite important. Other things too. So you have two kind of things that I want to end on here. One is minimal debugging. So you're all getting into the point where I'm guessing your projects are getting quite complicated. You have a lot of moving pieces, right? Maybe a lot of classes, a lot of files, a lot of functions, and things are getting a bit muddled. Well, if you have a testing framework and you run your test suite, the test suite's basically just a collection of test cases that you would run. If you start seeing failures, you know exactly where the problem is, right? You don't have to go through every single line of your code, print one, print two, print n. If you went down this branch, print here. If you went down this branch, print here. You know exactly where the failures are happening and you can zone in right on that problem. Then you do that trace debugging, right? Then you figure out what variable's wrong and right. But this basically is kind of like a laser focus on where the problems are. Obviously, if they're all passing, then you're out of luck. You probably need a better test case. So there is that. There is also this notion of testing kind of enforcing decoupling. And if you remember from last time, we talked about cohesion and coupling. And coupling was where we're trying to, or decoupling is where we're trying to break apart our classes, make them more focused and more refined. If you're writing test-driven development based like test cases, you're effectively forced to decouple your code, right? Because you're writing your tests that are very particular to specific functions and functionalities. And if your test case is like doing a million things, then it's going to be very tricky for um, your test cases to all show green. You're going to get very messy results. So by writing very laser focused test cases, that means that your functions all have to be very well focused, meaning your classes are going to be focused. It kind of bubbles up quite nicely in that regard. And last but not least, it's a professional type of thing too. So you get nice clean code. You end up with elegant code if you take the time to refactor nicely. And ideally, if you save that time by doing testing while you're developing, you can shave off a decent chunk of time from your schedules because you're not spending 20 months testing. It's all interwoven with your development. But you should still take the time to properly test. Don't like just get rid of it altogether. All right, that is enough for today. So on Friday, we'll go over some of the different types of testing, do a little bit of Python, and then Monday we will do a lab, and then Wednesday you got Thanksgiving break. It's going to be lovely to have a nice break this year. All right, any questions at all? Or are we all good? Let's get some doggos here. We add this to the artifacts folder. Because mine is submitted, I don't feel like changing. Oh, you mean the, are you talking about unit testing? I guess I'm confused. So is the question, do we have to do unit testing in our homework? No, there's no testing homework yet. Skip my first message. Yeah, no testing in the homework. There will be testing for your term projects. No testing for the homework currently. Oh, it'll be fun. It won't be so bad that you lose a ton of time. Let's see. There we go. We'll talk about the structure of it later on. Basically, it's going to be in the main source file, probably. Sorry, I'm realizing I'm responding to 3 different conversations at once here. Yeah, your test code would be separated out. It would still be a part of your project code base, but it wouldn't just be in your main project file. It would be in like a tests folder or something like that. Alrighty, I've kept you all over a minute if you haven't popped off already. But yep, I will see you Friday. We will wrap this up and it will be glorious. All right. Have a great Wednesday, everybody. Bye.